Hello everyone, I'm Ridhima from Saurabh's classes, and here we are solving our IIT JAM MS 2023 questions, right? So this is question number 22 in front of you. So let x be a random variable such that the moment generating function of x exists in a neighborhood of 0 and expectation of x to the power n is given by a series and n is equals to 1, 2, 3 up to infinity. So you have to find out the probability of x minus half greater than 1 equals to how much. So now this is a power series and we have to find out this. So this can be written as, so basically P of probability of x minus half greater than 1. This can be written as probability of x minus half greater than 1 plus probability of x minus half greater than minus 1. Correct? So this can be further calculated, and this is x greater than 3 by 2 plus probability of x greater than minus half. Now here we know that the expansion of an exponential series, let's say e to the power x, is equals to summation r x to the power r by r factorial. Okay, this is the expansion of any exponent. Now moment generating function is basically expectation of e to the power tx. So this, therefore from here I can say that e to the power tx implies summation of r tx to the power r by r factorial. Now if I am taking the expectation, that is e of e to the power tx, this implies summation r expectation of t to the power x to the power r by r factorial, right? Now so if you expand this, okay, one mistake here, that is should be less than here. Now so let us solve this, that is expand this, that is here this is M.Sc is equals to summation r is equals to 0 to infinity t to the power r by r factorial expectation of x to the power r. Now this is exponent of expectation of x to the power r series, which is similar to this. This is x to the power n. So instead of n, if we replace it with r, that is this will be replaced by r, and every n will be replaced by r. So we have this expansion. So let us put this, that is minus 1 to the power r 2 by 5 minus 1 to the power r 2 by 5 2 to the power r plus 1 by 5 plus 1 by 5. So this is the expansion of the expectation, and we already have 2 to the power r by r factorial, and the summation r is equals to 0 to infinity. Now let us multiply, that is r is equals to 0 to infinity minus t to the power r by r factorial into 2 by 5 plus, again we can take summation r is equals to 0 to infinity. Let us take 1 2 outside, and we have 2 to the power r and t to the power r, so 2t to the power r by r. Okay, we don't have here r factorial, yes, it is by r factorial plus, again summation r is equals to 0 to infinity t to the power r by 5 r factorial. So this is the expansion that we have got. Okay, now so from the formula of the exponential here, right, that is summation r is equals to 0 to infinity x to the power r by r factorial is e to the power x. So of course here we can easily write down the same thing, that is this is equals to summation r 0 to infinity minus t to the power r by r factorial. So this is e to the power minus t. Sathe we have along this we have 2 by 5 plus again we have 2 by 5 and this is e to the power 2t plus e to the power 1 by 5 into e to the power t. So this is the expansion form that we have got. So now since we have got this expansion here for discrete variable, now x tends to take the possible 3 values as per this expansion, that is -1, 2 and 1. The probability of these from the above expansion, so this is as this is clear, 2 by 5, 2 by 5, 1 by 5. Now this is the probability. Now we already have a probability that we have to solve, right? And which is this. So therefore, probability of x minus half greater than 1 is equals to probability of x greater than 3 by 2 plus probability of x less than minus half is equals to, so greater than 3 by 2 is, that is the 2 is the extreme value, so the probability is 2 by 5, plus less than half is we have -1, so the probability is 2 by 5. So the answer is 4 by 5. Question number 23. Let x be a random variable having a probability mass function px, so this is PMF, which is positive only for non-negative integers if probability of p of x plus 1 is equals to log 3 by x plus 1 into probability of x. Now from this I can compare it with the Poisson distribution, which is probability of x plus 1 is equals to lambda by x plus 1 into this. That is the PMF of the probability distribution in this case. So if I compare this and this, then I can say that lambda is equals to ln3. Now we have to find out variance of x. We know in Poisson distribution, variance of x, if x follows Poisson with lambda variable, then variance of x is equals to lambda. So here which is equals to log 3. So the answer is A. Let us have a look at the next question. So here we are given let x1 and x2 be independently identically distributed random variable having the common probability density function, that is CDF, is given, and x1 is defined as the minimum of x1 x2 and x2 is defined as the maximum of x1 x2. Then which one of the following statement is false? So we have to check the options. So let us start with option number C, where E of x1 is equals to half. Now let's say the explanation here is basically the PDF of this form will be n into 1 minus CDF of n minus 1 into the fx form, right? Now here n is equals to 2, 1 minus e to the power minus x to the power 2 minus 1 is 1 into fx, that is e to the minus x, right? So now if we solve this, so this is our x1 here and n is basically, okay, we also have a 2 here, right? So now this is the thing. Now from here, so we get x1 is equals to 2 to the power e to the power minus 2x. Now this is basically our exponent with 2, so that is 2 half of this. So that means if we solve like this, then this is correct. So this is check. That means option C will not be one of the answers. Now let us check the next one. That is, let us now check A. Let us check option B. Okay, that is 2 of x2 minus x1 follows x2 square, right? Here we are going to use the formula xr plus 1 minus xr follows um, this is our, yes, so this follows the exponential of n minus r of theta. Okay, now here if this is basically x of 2 minus x of 1, this is exponential of 2 minus 1, that is 1 into theta. Now this is basically the gamma of 1 comma 1. Now if we multiply it of 2x2 minus x of 1, then this follows gamma 1 of 1 half, that follows basically chi square with degree of freedom 2. That means 2 times of this is follows this, so this is also correct. The shaded ones are correct. Now we are left with 2 more. So now let us check the next one. So next here is, let us try to find out for the F distribution. So here we will just look at the formula and then we will understand whether this will be incorrect or not. So we know that if we have one variable, that is say x1 follows chi-square distribution with degree of freedom v1 and x2 follows chi-square distribution with v2 degree of freedom, then x1 by v1 by x2 by v2 basically follows F distribution with v1 comma v2. So now this is somewhat replicated here, and if we solve, we think we will get the value. So this is also not incorrect. The next, let us try to find out for the D1. So the D here it is given is probability of 3 of x1 less than x2. Now x1 x2 are the equally likely event. What is the equally likely event? Is that probability of this less than this is also equals to probability of this less than this, x2 less than 1, x1 less than. That is what the equally likely means. So what we can write down here is basically half into probability of 3 of x1 less than x2 plus half of probability of 3 into x2 less than x1, since these are equally likely events. Now if we go for this, so we have to take 0 to infinity, and this will be your from 0 to infinity to so here after integrating this part, so we have 3x1 to infinity dx1. Now this is equals to 0 to infinity e to the power minus x1 e to the power, now this is minus 3x1 minus this we will put, right, and then infinity is this, so we have dx1. So this is 0 to infinity e to the power minus 4x1 dx1, correct? So after solving this, we have e to the power minus 4x1 by minus 4, and this is within the interval 0 to infinity. So that is so we will have 1 by 4 as the answer, right? So this is obvious that the probability is 1 by 4 here answer, but it is given 1 by 3, so definitely this is incorrect. So the correct option, I mean, according to the question, which statement is false, according to that, option D should be the answer because this statement is false. Okay, so let's have a look at the next question. That x1, x2, x3 and x4 we observe value of a random sample from a normal distribution theta sigma square, where theta belongs to the real numbers and sigma is greater than 0, and both of them are unknown. Suppose that the sample mean is 1 by 4 summation xi is equals to 3.6, and the unbiased estimator of the sample variance is 20.25. So for testing the null hypothesis is what? That this parameter is 0 against the parameter is not equals to 0. The p-value of the likelihood ratio test equals to how much? That we have to find out. So first let us write down the information that we have gathered from the question given. So first of all, there is x that follows normal distribution with theta and sigma square as parameters, both unknown. Now, next information given, sample size is equals to 4, x bar is equals to 3.6, and s square is equals to 20.25. Null hypothesis is thus that the parameter is 0 versus alternative hypothesis that the parameter is not equals to 0. Now, so basically this is a two-tailed test. Two-tailed test means it looks like this. Right. So what are the test value here? Test value we can use here is t, right? Degree of freedom is n minus 1 c because both of them are unknown. So that is x bar minus theta according to the null hypothesis by root over s square by n. Now here that will be your t3 is equals to 3.6 minus 0 by root over 20.25 by 4. So that is your T3 is equals to 3.6 into 2 by root over 20.25. That is your something around 1.6 approximately. So that means this is 1.6, this is minus 1.6, and the critical region is this. So that means we have to find out the probability of this plus this, right? So this is our two-tailed test. Now, in order to do that, what we have to do, we have to find out the following. Now, so I have to solve 2 of probability of t with degree of freedom greater than 1.6. Now, so if we calculate this, the answer we will get is 0.208. So, do we have this answer in the solution, in the options? Yes. So, option B is the correct answer.